Good morning, good afternoon, good evening, folks. Thank you for joining this webinar. Today we have PREspective, our partner, with us to help you understand how PREspective is helping customers create digital twin. I'm Deepak Barwal, part of the strategic partnerships team, and my responsibility is to help get the partners, right set of partners for the developers and customers for APAC region. And I'm thankful for Daniel and Matisse to join us today from Unit 040. And the offering that they have is called as PREspective. PREspective essentially helps create a digital twin, which essentially is a virtual replica of any physical machine or object to do various things on top of it. You can do simulation, you can do virtual prototyping, you can do economic studies, you can create actual live digital twin to test the throughput. Of course, the usage are multifold, and that is where today Daniel and Mattis will be speaking about the various use cases and how companies like Festo, Toyota, are leveraging the power of real-time technology and PREspective to create the digital twin and help in creating beautiful solutions. So over to you, Daniel. Thank you so much for joining today's call, and I'll hand it over to you to take us through the presentation and through the demo.
All right, thank you very much, Deepak, for that great introduction. All right, I hope everyone sees my screen and can hear me loud and clear. If not, let me know, of course. And thank you very much for having me and for giving me a little of your time. So yeah, I can introduce you to our solution called PREspective. Maybe some of you are already familiar with PREspective or with Unity in some way. So some things talked about here during this session you may already know, but in general, this webinar will focus on an introduction to our software and on how to use it and implement it in your workflow, and of course, show you the basics of the software itself in a short demo. A quick look at the agenda for today. We will try to make sure we will finish up within the hour, and we will focus mainly on two things. A short basic 10-minute introduction to PREspective, where I will focus on the high-level use cases, which problems it solves, and some success stories we would like to share with you. After which my colleague will give a 35-minute demo of the basic features of PREspective. And at the end, to wrap it all up, and if needed, a Q&A. You can send your questions through the chat function of this webinar below in the screen, which will be followed up at the end of the session. But first, let me start by quickly introducing myself. My name is Daniel. I'm the commercial director of Unity-ANZSEA, which is the company that develops PREspective. We are based in the Netherlands, so if my English is a little off, sorry for that. More importantly, for this webinar is the attendance of my colleague Matthijs. He's a software engineer who works on the core of PREspective and is also a key member of our academy team. And he will be the one that's going to demonstrate you PREspective later on. So as said, PREspective is a product of Unity-ANZSEA. We're a company that develops software solutions for industrial purposes for actually almost 15 years now. Started as a startup at the university. We quickly became suppliers for big companies as Siemens, Bosch, Shell, and ASML. In 2017, we started with the development of PREspective as we saw a growing need for virtual prototype and digital twin solution. And that's when we stumbled upon Unity as an open game engine. And now, 3 years later, PREspective is a proud verified solution partner of Unity. And what that means is that on the one hand, our solution is verified by Unity's technical team, and on the other hand, can be sold by Unity's sales team. We work very closely on serving industrial clients with our joint solution and working closely on delivering a robust tool set for the industry. Yeah, we work for and with a lot of companies you may recognize, and we love to explore the possibilities of working with you or your company as well. what I hope you will learn from this webinar is that solutions like ours are in high demand because industries are changing. Development cycles must be shorter, safer, and more agile. And this asks for a new kind of working. And with the use of PREspective and Unity, we help clients achieve reduction of total cost of ownership with up to 30% because company departments like engineering, mechatronics, software development, and even sales and training can work more parallel instead of sequential. And because of this exact same argument, in combination with less physical prototypes, clients can go faster to the market as well, and saving enormous sums of money. And last but not least, I understand that starting with digital twin software or virtual prototype software can be considered an open field where you maybe don't know where to start. And that's why we say that the proof is in the pudding, as they say. So we gladly offer you a free trial of our software, and are also very much open to the idea of setting up a call with you to discuss your exact needs and wishes and help you find your way. And just reach out and we are there. Okay, so very quickly an introduction to the tech behind PREspective. What we basically do is that we enable Unity users to set up a digital twin of their system or factory and connect that to logic, and thus creating a fully working virtual prototype. We do this mainly for the industry in the verticals that we call ATM and AEC. So that stands for automotive, transportation, and manufacturing. And AEC stands for architecture, engineering, and construction. And the main reason for that is that these industries typically have a very expensive development phase with high chances of failure. For example, in ATM, we focus on companies that build machines or production lines. And in AEC, you can think of companies that build bridges or tunnels, for example. Well, basically companies that have moving objects or parts in their system or products. And what we see is that a lot of these companies are wasting tons or even millions of dollars on time and materials and resources during the development phase. And the way a lot of companies work is that their engineers develop a machine or a system of some kind in a CAD software tool, after which they immediately start producing physical prototypes. And they have absolutely no idea if their drawings will work in the real world. So they already know that there are going to be a lot of iterations with expensive prototypes. And the problem with that is that other disciplines within the organization, for example, software engineers, have to wait to start writing the behavior of the system. And of course, when they do start, they encounter all sorts of mistakes that have been made during the development phase. So they have to start again and so on and so on. And meanwhile, they have a very anxious client or a boss that is waiting on the system and demands that everything needs to speed up. That, of course, is very stressful and not at all efficient. So with new technologies like ours, and of course Unity's, companies are now able to do this exact same development cycle, but in the virtual world. In short, we call this virtual prototyping. So far less physical prototypes, far less wasting of materials, far less wasting of time, and much more a multidisciplinary way of working. And with PREspective, we offer users a way to build and validate your system. And the keyword here is validate, because we validate the virtual prototype before the physical version is built. And the result, and of course, our biggest selling point, is that this results in up to 30% less total cost of ownership. And we recently did an intense case study together with Unity for our client, the ANZSEA, which is based in the UK, in which the client stated that they could develop up to 65% faster using Unity and PREspective than they currently could do. And that's amazing, of course. So yeah, the way we operate is that our tooling allows users to import their data, mostly as said, a CAD model of some kind, and connect that to the actual control software, and yeah, we'll basically make it come to life. So the real control software runs the virtual model, as you can also see on this slide. And now, when this model has come to life, you can do all sorts of things with it, such you can see on the next slides. Well, they can use it, for example, to make conceptual visualizations, for example. And this is a very big use case because this is a visualization that a user usually can set up in a day, and from there on can showcase it to all kinds of stakeholders, including customers and colleagues. You can basically use it for design reviews, for marketing and sale purposes, And it's the groundwork for use cases later on in the development cycle. And the great thing is that you can even add a certain custom-made UI to it. So it's not only usable by the tech people, but also, for example, for people in sales to really show customers how the end product will look and operate. And you can even send it as a link via our WebGL functionality. After setting up your conceptual visualization, a lot of our customers use Unity and PREspective for throughput analysis, which basically enables users to test their throughput and to measure if they can do it with less resources. Or, for example, see how the system will react if throughput would be sped up, or what happens when you add an extra conveyor belt or a robot arm. And this way, users can measure the total cost of ownership, and this can really work as a sales accelerator for our users. Virtual prototyping is the use case we see the most among our customers, and I think I really covered this already in the previous slides, but the main selling point here is that it cuts the amount of physical prototypes and thus money. And it enables a shorter time to market, which in itself also has a big impact on the return on investment, of course. So yeah, those are the main use cases, but of course there are many more use cases for using digital twin technology. You can imagine that if you have a certain system set up in your virtual world, you can also start with planning optimization and collision detection. And that's the power of Unity, of course. Users can place virtual sensors, connect to external data, for example, IoT data, and track everything in the virtual world and use this data to validate assumptions or like I said, throughput analysis. So yeah, some success stories we did with customers that we are allowed to share. First of Festo, Deepak already mentioned it. It's a big multinational automation company, and Festo uses PREspective to import their own library of components and products, including real-life behavior, and provide that to their customers. And using a variety of parameters, customers can try Festo products before ordering them, which is very useful, of course. So you can think of this case as sort of a configurator for sales purposes. Mars Foods, they use PREspective for testing their machine lines. They focus very heavy on the material handling part of, and the biggest KPI for them lies in the fact that they want to optimize their throughput. Of course, this is very difficult to do in the real world, so they use Unity and PREspective to do this. And what PREspective's biggest sell in this specific case is that we offer an extra physics layer on the physics that Unity uses. That combines discrete event simulations and 2D physics for even more precision. And the science behind that is pretty complex. So if you want to know more about that, I can connect you to someone smarter than me. But this is one of our most innovative features. And then one of Toyota's subsidiaries is a company that is a world player on baggage handling systems. And I've seen on the video here, it's hard to see actually, but there is a red and green lines that show what the virtual sensors see. So they use PREspective for setting up this entire virtual environment to debug the machine and see if the software works correctly. And once set up, they just let the machine run for hours and hours and pretty much wait and see if something happens that they did not anticipate on. And of course, debug it in real time. And what's pretty awesome is that Unity allows them to use certain assets as well in this scene, such as avatars and luggage. And on the video on the left, by the way, you see that the virtual model is actually hooked onto the actual PLC. Yeah, so that's it for me. As said in the beginning, this is just a very brief introduction. If you want to know more, please visit our website or ask for a private, more in-depth presentation of PREspective. And we are happy to set that up either through me or through Deepak. Also, check out our free trial and use our online academy as your guide to the first basic step, and let us know if you need any help. And with that, I will stop sharing my screen and we'll give it over to my colleague, Matthijs. Thank you very much.
Okay, so let's see. Share my screen. Yes, this one. So everybody can see my screen now, I think.
Yep.
Yes. Okay, great. So today I will show you how to set up a basic simulation, and I'm going to show you how to create this 3D printer I have set up already. What you see here is the end result of what we're going to make, which is there are 3 motors on this system, and they drive the printing panel here and the 2 axes of the printer head. And this simulation is connected to an external controller, and in this case it's a TwinCAD PLC, which is now controlling this printer. I've got a little bit of sample code here, which is nothing special. It's only for the demo, but it shows you, well, it's more like a proof of concept that you can actually connect this to an external controller and have it run on any behavior you like. So let's begin. I'm going to I'm going to turn off this simulation now. Okay, yes, it's now shutting down. And let's go to our original import where it all began. So this is the original imports of the 3D printer. Let's see. And as you can see, what we do first when we get a model is we organize the model to make it easier to work with. As you can see, it comes with a whole bunch of game objects that do not come organized in any way. They have a name, but those names aren't always as easy to understand as you hope. And for that, we have a few organization tools. We also sometimes need to do some work on the model itself. For example, aligning objects or changing pivots or things like that. Can I get this thing gone? It's bugging me top to the bottom. No, I don't know. Anyway, so I have prepared a kind of issue here, and that is this game object here. I've marked it red, and this is an axis to drive the rubber band that is driving the motors, and we want to be able to rotate it around its axis. And as you can see, the pivot is currently not in the right place. It has an offset, and we want to fix that. So I'm going to start fixing that pivot with a tool we have created. So I'm going to create an arbitrary empty object which serves as a pivot point for me now. I'm going to utilities, and there I have my pivot tool. And with this pivot tool, I can set the pivot of a specific game object to match with the pivot of another selected game object. So I could drag this empty game object in here, and I could select any game object I'd like here. So this is the game object of the axis, and then I could say move and or rotate it, and then I change the pivot. But this pivot first needs to be set in the right position, since we want the pivot of the axis in the center of this. We first need to set this at that position. So in utilities, I also have a alignment tool, and with this tool I can align game objects. So I want to align this empty game object, and I'm going to rename this pivot object, for example, for now. And I want to align this object to the axis. And I'm going to align the transform of the pivot to the transform of, to the 3-point circle of the axis. Let's switch to shaded wireframe for now, makes it easier. Because what we're going to do is we're going to draw a circle over the axis, the cylinder part of this axis. And that circle will determine the center of that circle. And I'm going to align the pivot to the center of the circle. And in that way, I'm going to align it, the pivot to the exact center of the axis. So I have my circle points here. I'm going to place these points on these vertices. That seemed about right. So the circle is now set up, and then I'm going to align the pivot of this transform to the 3-point circle here, and that's the point where this blue line originates, and this blue line is the indicates the origin, the normal of this circle at its center. And I'm going to change it to only set it to position for now, because I want to keep the rotation of this game object as it is. And then I'm going to select apply alignment, and as you see, it just jumped to this position. So my pivot object is now neatly centered on this axis. Then I'm going to go back to my pivot tool, and I'm going to do exactly as I explained just now. I'm going to select the pivot object as the pivot I want to use, and then select the game object that I want to change the pivot of. And then I'm going to set the pivot move to the pivot type to move, change pivot, and now the pivot of this game object jumped to this position. I can now safely remove this empty game object, and my pivot has now changed to the position I want it to be. And it's easy as that. Sometimes these models don't come perfectly aligned from the model makers with the pivots all over the place, and this will save you a lot of time sending the model back to the model makers and waiting for them to fix the problem, and you being able to recontinue your work. Next thing we need to do is align this axis on this other axis, and for that we can also use the alignment tool. So let me open it up again, and this time I want to align this gear, I should call it a gear, onto this axis. And let's see which object is that. Let me select the object. Yeah, that's this one. And so I'm going to select this parent object. No, I'm not. I'm going to select this object actually. Okay. And now I'm going to do the same thing actually. Since this pivot is now in the right position, I can align it from its pivot. If this pivot was in a totally different position, I could use the circle tool on both of these objects, where I would align this circle, excuse me, with this circle. But I have just set the pivot to the proper place, so that's no problem anymore. Select the circle here. Let's see, where are my points? Either all the way here, and I'm going to align those points to, I don't want this object to be selected, otherwise the vertices won't snap. Okay, so one is, at least one is still off. That looks about right. Yeah, okay, and once again I'm going to select this to only apply position, and there it is. And then I'm going to slide this back just a tiny bit so that it sits nice in the middle there, so something like this. So this should be fine. So as you can see, this gear is now, oh, this didn't come with it. Why didn't it? Because I just dragged only this object, and I need to drag the entire the parent, not the game object itself. Okay, so this is now sitting neatly on the axis and is now ready to be rigged with the kinematics, since the model is now fully prepared. So I'm going to show, I'm going to switch to, oh no, sorry, I'm forgetting something. We can actually group different kinds of models easily. For that we have a mesh query. For example, if you want to group, let's say, all blue objects in this scene, you can actually do that. And for that we have developed a mesh query. So I'm going to select one of the objects with the blue material, and I'm going to select this object, and then I can select a few settings on which objects I would like to find in the scene relative to this object I have selected here. So for example, I could do a material check, and then I can select similar, and it now finds all the items in the scene with the same material, as you can see here. But I could also do, okay, check the mesh volume, and I allow it to deviate by 5%, select similar, and it now gives me all these items, for example. This tool can, for example, be used to find all screws in the model. Some models come with 100 screws, and you don't need any of them in the simulation most of the time, and you can select them all at once and then simply delete them or group them and hide them, whatever you like. That's all possible. So if I select the mesh area and the volume, and let's say if I don't want to deviate anything, okay, wait, I'm going to reopen this because it had everything selected already. Mesh tools, mesh query, mesh area, and mesh volume, select similar. Oh, it doesn't find anything similar. Let me change it to 1% maybe. Oh, select similar. No, it doesn't find anything similar. Well, do I have similar objects is the question. Maybe I do not. I know I have these objects similar, at least a few. Yes, so as you can see here, it now selected all of these 4 corner pieces that it found, which happen to be exactly the same model, just copied 4 times in this model. And this way you can find similar objects and group them, because the next tool we have is the grouping tool, and that one you can find here, and that's very straightforward. You select every object you would like to have in one group, and in this case I have these 4 corner pieces here, and I can rename this group in this case to the corner pieces, and group selected objects, and then here in the bottom I have now a group with the corner pieces, and these are all the 4 corner pieces here. I can close this group, and this will force all these meshes to behave as one mesh, but it's in a non-destructive way, which means a new mesh will form and it will replace the ones originally, but it will store the old meshes in the background, because if you want to ungroup them later, you can without losing the original meshes. And it will also, if you disband the group entirely, it will also place it back to its original parents, and you will be able to fully revert to its original setup, if you like. I have fully organized this model in the scene I call the cleaned scene. And here I have set up a few groups. And here's a 3D printer object, and I have the support objects, which we won't be using during this simulation, which are, for example, the beams and these blue objects mostly. So I'm going to disable them for now. Oh, I haven't included the beams in here. Oh, that's in the frame, of course. The support objects are these blue objects, namely the frame. There you go. And these are the printer components, the motors, the printing panel, the sliding axes of the motors, etc. Everything that is needed for the simulation itself. And to get things working, we need to rig these with the kinematics, and I'm going to show you how to do that for one specific thing, and that's this motor driving this axis and this head. And that's where the actual kinematics of the simulation come into play. So our To begin our simulation, kinematics always need a controller. So I'm going to add a kinematics controller at the very top object of this printer, and this will check every kinematics parented below it. You basically don't need to worry about this any further. It just manages everything it finds parented underneath it. And I'm going to limit this object to a wheel joint so that it can only rotate it over a certain plane. So I have this game object, which oh, this is the entire motor. I want this part. This object that we had just repositioned, it's lost its red color, but that's okay. And I'm going to add a wheel joint to this. And this will, there are the gizmos. This will allow me to limit this rotation onto a certain plane. It will spawn with a radius of 1 meter by default, but we're going to change this to something smaller. Okay, so let's set this to even smaller than 1 centimeter. And I'm going to set the direction. As you can see, it's now not orientated in the proper direction. So I'm going to set the axis direction, which is now this green line, and the blue line is the forward direction. And let's set it, I don't know what this, what the direction should be right away, but let's try. Can I set it to forward? Yes, but that's the axis direction, so I'm going to set it to right and this to forward, and there you go. That's the proper plane. And if I now enforce this, this should be locked into place. So I can still rotate it over this axis, but I can no longer rotate it over this axis, as you can see. So it's now been limited onto a certain direction of rotation. So that's our wheel joint. And then we have this object which it drives through this rubber band, and we're going to do the exact same thing here. So I'm going to add a wheel joint here, and let's bring this down as well, and its pivot point is over here. So let me reposition my camera, and I'm going to set this that's the forward, so I want this to be the axis. I wanted this to be right. Yep. Okay, like that. And I'm going to enforce it, and the same thing happens. It's now able to rotate over this side, but no longer over this axis. Yep. Let's see. Yeah. Okay. Great. So these two now are limited in their direction of rotation. And next thing we want to do is we want to create a relation between these two, because this rubber band drives this axis. As soon as this gear rotates, we want to create that relation. And we go to either of these wheel joints that I've just created, and there you will find an option to create a new transform relation, and it will ask to select an opposing relation instance, and I will select the second wheel joint. I can see that this is a wheel joint because of this icon here, and can simply drag this in. And if I rotate this now, you can see that the other game object rotates along with it. Unfortunately, it rotates in the opposite direction, and that's because of the way the wheel joints are set up, because this axis is oriented in this direction and this axis is oriented in the other direction. The direction of rotation is also mirrored, but I can easily fix this by selecting rotate. Motion is reversed, and it now rotates along with it in the same direction. So this is now set up as the rubber band would drive that together. Let's animate it for now, because this is only the kinematics, but we can't actually we can actually drive it through a motor script. So I'm going to create a motor component on the parent called motor x-axis here. and I want to add a standard component, and let's add a stepper motor, the physical component, and this will ask for a wheel joint, and it has directly found a wheel joint. As soon as you create this script, it will look for any wheel joints on this game object or any of its children, and it just found this wheel joint here and has selected that as the wheel joint. And I want to create a control panel for now because we haven't connected it to an external controller, and this should now be able to drive the wheel joint. So in the control panel, I can now say start rotating. Okay, and as you can see, it now starts rotating these wheel joints and automatically starts rotating this axis along with it. Next thing we want to do is have this axis drive the printer head. This axis drives this printer head through this rubber band you see here, which moves this component over this rail, moving the printer head. But this can move in any way it currently likes, so we have to limit that as well. And very similar as we limited the rotation of these gears and axes by using a wheel joint, we can limit the translation of this game object using a prismatic joint. So I'm going to select this object, yes, which is this one here. Oh, I don't want to use the belt, so it's this object, yes, this one. I'm going to add kinematics a prismatic joint, and a prismatic joint needs a spline which describes the path it's allowed to move over, and I can create a spline by going to utilities, create a spline. In here I'm going to parent the spline under the axis here, and I'm going to call this prismatic spline, but you can name it whatever you like. And then I'm going to position the spline so that it actually accurately describes the motion of the allowed motion of this game object. So let me quickly align this. So it doesn't need to be exactly spot on, since it's a relative position to the spline. So which means that if I set the spline anywhere in the world, as soon as you initialize the joint, it will find its relative position to the spline and it will work from there. So I'm going to simply eyeball it for now. You can actually align it with the same alignment tool as we used earlier, but I'm not going to now, just to speed up the process. So this is approximately centered with this rail. And I'm going to bring in the second spline point because that's a little bit too far away. So just drag this in. Okay. And then I'm going to set this spline as the constraining spline for the prismatic joint, which you can do at the bottom here. So just drag this spline in. And I'm going to enforce it. And the same kinematics controller which handles the wheel joint will now handle this object over this prismatic joint. I can still move it over this direction, but it's no longer able to move in any other direction, as you can see here. Okay, so let me set this back that it aligns like this. Okay, great. And now we also want to have a relation between this game object, which this rail here, this axis, that actually drives this component through the rubber band. And very similar as we did with the two wheel joints, we select the object, the wheel joint here. And now we want to create another relation, but this time not with the wheel joint, but with the prismatic joint. Just drag it in here. And if I now rotate this, you can see that the wheel joint starts moving, as you can see. And it's limited by the end of the prismatic joint. As you can see here, the spline stops here, and that prevents also the wheel joints from rotating any further. And that also applies for the other end of the spline. So if I now go to play mode and I go back to my motor, And this is all no longer aligned, as you can see, because I have not created a relation between the head and this rail yet. But just for this demonstration, I go to this motor object and I now start rotating. Oh, that's the wrong way. I just hit an error. I want to rotate in the counterclockwise direction, start rotating. It now rotates this this rail using the motor component and now hits the other end and goes back into an error. So if I'm going to skip where I have prepared all kinematics, so that's this scene, I don't need to save it. Here we have set up the entire kinematics and I can show you what this end result looks like. So select this motor. Let's see, where have I set this? Oh, that's on the control panel. Is it this motor? Yeah, this is the motor, and it now moves this rail, but the printer head now moves along with it. So I'm going to stop this and then start this one in continuous rotation, and now moves the head in the other direction, as you can see here. So this is now working properly. The last thing we need to do is actually connect this to an external controller. And we can do that using a logic simulator. And we can find the logic simulator here under the tab logic, add the logic simulator. And this will add this script to the scene. And we can connect individual components to an external controller using this component. Each component you wish to connect to an external controller requires its own logic component. So for this motor, for example, again, I'm going to create a standard components, go to the motors, and this was a stepper motor, right? Yes, it was a stepper motor. I need to add a motors driven stepper motor, the logic component. I'm going to parent this logic component under the pre-logic simulator, and this requires you to define a stepper motor that it controls. So let's see, where did I actually put it? Here is the driven stepper motor script. It's on this body object, so I'm going to drag this body object into here, and then I need to set up the settings for the component. So I'm going to do that quickly. So this needs to change to driven stepper motor, and that's okay. And then for the simulator, we need to give it a name. So I'm just going to call it demo PLC. These settings are all fine by default. We want to use a TwinCAT ADS connection. The XML file path, that's the file name you want to write the IOs to. So I'm going to say demo plc.xml. The server name is the demo server. The IP address you can find in this case in the TwinCAT settings. So I'm going here, and in the AMS net ID is my my IP is shown. Oh, that was not the right setting. It just jumped. Okay, here I'm going to add port 851, and I'm going to this fairly quickly because all this is explained in further detail in our documentation and tutorials online. But I just want to show you that you how and that you can connect it to an external controller. So these settings are now set up. I'm going to export our XML, and now it says, oh, I have successfully exported our XML, and no duplicate addresses found. Okay, that's good. And then I'm going to open my XML, and this now shows me my my IO definition. And here you'll find, okay, I have one driven stepper motor logic found, and it uses the IO-I velocity and the IO-I position degree and position step, etc., etc. So this looks fine. So I have Visual Studio opened, This is the finalized PLC, but let's create a new PLC project quickly, and demo PLC. I don't know if I have already one, so I'm going to just call it 2 for to be sure, and let's create this as a standard PLC project. Call this PLC. Okay, and then here in TwinCAD it generates a folder destination for this project, and we need to input that folder destination in here, because next thing we're going to do is export our configuration files, and it just did. And what it does is it writes files to our TwinCAD project, and our grant variable list here, general variable list, we can now add an item which has just been created by our team. That's the GVLS here. Let's add this and do the same thing for our POUs. The driven stepper motor, there it is, it just generated it. And then I'm going to activate my PLC. It doesn't want to, because let's restart this in run mode. I'm using currently an extension to Visual Studio. I recommend you using the default, how do I say it? The regular TwinCAD program, but mine is bugging out. My UI isn't showing properly, so I unfortunately cannot do that. Let's see. Is it willing to work with me here? It's restarting. So let's give it a second. Extension TwinCAD. I don't know what it did, but I think I just crashed on me. Okay. Can I do that again? No, it completely wiped my project. So that's great. Thank you, Visual Studio, for that. Okay, I think I'm going to skip the creation of the project for now. Once again, you can find that in our documentation as well online. It's fully described in full detail. So I'm just going to go back to our original PLC project. So let's open this. And I'm going to jump back to our scene where I have set up all logic already. So I have now only set up driven stepper motor here. And if I go back to our last scene, I have our 3 motors set up, which is this one for the x-axis. There is this one driving the y-axis of the printer, and there is one on the bottom here. There it is, which drives this worm wheel, which drives this plateau up and down, and that controls the z-axis of the printer. And let me activate this configuration. This will take a few seconds. Yes, let's restart and not wipe my entire project this time. Okay, great. Login. Let's go to reset call, that I have my default values, and I'm going to go to play mode, and it now registers the controller. As you can see here, it's connecting to the TwinCAD ADS, and then okay, activation started, done. Okay, great. So it's now connected, and if I now it's not doing anything yet, but if I now start the simulation, it now raises the platform, and it actually gets commands input through the external controller, and as soon as it raises the platform to the very top, the printer head will start moving. So this is in a nutshell how to set up an easy and simple project with some basic demo behavior on the background. And then I'm going to give it back to Daniel, I think. Yes.
All right, thank you very much, Matthijs. I hope this very basic demo of PREspective will let you have a deeper insight into what you can do with it. I understand for most people this might be a little technical, but of course we're happy to demo a more in-depth use case for you. Upon request, you can reach out to Deepak or to me, and then we can help you further. We did have some questions. Let me see if we can do some verbally right now because we have some time left. Yes, there was a question for the free trial. Of course, you can download the free trial. You can go to our website, which is PREspective-software.com, and then you can click on the orange button for a free trial. You can also go to the Unity Asset Store from your Unity editor, and then you can search for PREspective or for Digital Twin, and then you can download the free trial as well. Is the webinar any value for new developers who are just starting learning game development? Yes, especially if you are focused on industrial solutions, as Deepak said, also in the chat version of the Q&A. Yeah, just reach out to us and we can help you set everything up. But basically, of course, you can do that. For any doubt, who can we contact? You can reach out to Deepak at unity3d.com and he can help you get more information on Unity and PREspective and how it can be used for industrial purposes. Yeah, what is PREspective was a question. Of course, we try to elaborate on this in this webinar. This webinar will be available for you on YouTube later on. Deepak, maybe you can elaborate on when they will have access to that, but I hope somewhere today or maybe tomorrow.
Yeah, I think by tomorrow it should be uploaded, and probably we can share the link over the email also to all participants. Okay.
Yeah. Some questions is it getting the live data from the hardware system and dissimulate it in Unity? Yes, you can connect to all sort of PLCs like Siemens, ABB, Allen Bradley, but also virtual PLCs like OpenCUA. But you can also connect to more different kind of external data like IoT or MQTT. So we have lots of possibilities to connect to external data. How can we get these assets? Yes, I already explained this. You can download it in the asset store or from our website. The question, this model has been imported from industrial CAD/CAM diagrams directly without any modifications. No, you can use the Pixies plugin, also available in the asset store of Unity, to import all sorts of CAD models. And the plugin will optimize the model so it can be used in Unity. Otherwise, it would be too big to handle in Unity, of course.
We can directly import DAA files, however.
Yeah, thank you.
That's the one exception.
Yeah. Yeah, I think those were the most questions I can answer right now. You can also look at the Q&A session for more questions that are being asked. Looking at our time, if you have any questions, please deposit them now. And then, of course,
few open questions.
Oh yeah, I see. Yeah. Well, very good meeting. Thank you very much. Has this been used in any real world application before? I'm not sure what you exactly mean, but of course our product is being used by real life customers. And if you need any specific use cases, we can help you with that. Is there any prerequisite setting from Pixies before importing to Unity? Maybe you can answer this, Matthijs.
Sorry, which one?
Is there any prerequisite setting from Pixies before importing to Unity?
I have personally never used Pixies. There are a few guys at the office that manage our Pixies, and I personally have no experience with it.
Okay. So if you have any technical questions please reach out to Deepak and we will try to follow them all up. We are more the high level team, of course, so the real technical questions can be answered by people smarter than us or than me for that matter. So yeah, I think I'm ready to give it back to Deepak.
Yeah, there's one more question which is from Mukundan. He is asking, is it compatible with IoT solutions like PTC's ThingWorks?
I will get back to you on that. I have no idea, but I'm sure someone at our team has, and I will make sure to reach out to you to answer that question.
Sounds good. All right. Thank you so much. Thank you, everyone for attending this session, and we'll share the recording shortly. If you have any questions, you can reach out to me on deepak@unity3d.com. I've posted my email ID in a couple of answers over there. Thank you for the session, Daniel and Mathis. We'll talk again soon. Thank you, everyone.